Welcome students. This video is about static friction and what the difference is in calculating coefficient of static friction or the force of static friction. So let's get started. In this first example, you and your friend push a 100 kilogram couch across the living room floor. The two of you together apply a force of 950 newtons. If the coefficient of static friction is 0.75 and the coefficient of kinetic friction is 0.55, are you able to move the couch? So if we're starting from rest, we aren't actually moving, then we are going to need to look at the coefficient of static friction. If we were pushing the couch and it was actually moving, either accelerating or even traveling at a constant velocity, then we could use the kinetic friction. So let's look at what we know. We know that the mass of the couch is 100 kilograms and that there is an applied force by you and your friend of 950 newtons, and there is a coefficient of static friction 0.75. And we want to know, is the force that we have here enough to actually get this couch moving, to overcome that static friction? So on your formula sheet, it says that the force of friction for static friction, coefficient of static friction times the normal, and there's usually a greater than or equal to sign here. And what that's about is, if you are actually greater than the static friction coefficient times the normal force, then you will be able to overcome the static friction and you will be able to get it moving. So that's the part we're interested in, because we want to know, will this couch move? So we're going to use the equal sign part. Now, we don't know the normal, so if we take a look at our free body diagram, we are looking at the forces acting on the couch, because it is the couch that we are interested in moving. So the couch has a weight, force of gravity, and the floor is pushing back up on the couch, which is the normal. Now the couch isn't moving in the y direction. It's not lifting off the floor, it's not falling through the floor. So those two forces have to be equal in magnitude and opposite in direction. So if we can find the force of gravity, then we know the normal force. Force of gravity is equal to mass times the acceleration due to gravity, which is 100 times 9.8, 980 newtons, which means the normal force is also 980 newtons. Now we can put that into our formula for friction, and we can find the force of friction. So our coefficient of static friction is 0.75 times by the normal force, 980 newtons, and if we put that into the calculator, we get 735 newtons. So what that means is that friction is pulling backwards against the movement with 735 newtons, but we are applying a force of 950 newtons. So that force is a little bit longer than the force of friction, which means yes, we are able to move the couch. And that's how you would solve that problem. Alright, let's do a second problem. A dog weighing 300 newtons harnessed to a sled can exert a maximum horizontal force of 160 newtons without slipping. What is the coefficient of static friction between the dog's paws and the snow? So let's start by looking at what we know. We know that the dog has a weight, or force of gravity, is equal to 300 newtons. And the dog can exert a force, so apply a force to the sled of 160 newtons. So that's the applied force. And we want to find the coefficient of static friction between the dog's paws and the snow. So if we draw a free body diagram of the dog, then the dog has a weight, force of gravity acting downward, the normal force acting upward, The normal force and the force of gravity should be the same length because the dog is not accelerating upwards or downwards. He's not moving in the y direction at all. We have an applied force, so the dog harnessed to the sled can exert a maximum force of 160 newtons. So the dog is applying a force to the sled, and then there's friction on the snow going back the other way. Okay, now we want to know the coefficient of static friction between the dog and the snow, so that he can apply that maximum 160 Newton force. So on our formula sheet, force of friction for static friction, the maximum is equal to the coefficient of static friction times by the normal. And when it's maximum, the equal sign is there, and that's what we're looking for in this case. We want to find coefficient of static friction. So if we are just starting to get this dog going, these two forces should be equal, the applied force and the force of friction. Once the dog is able to start moving, then that friction is going to back off a bit and the dog is going to be able to start accelerating in the one direction. But for now, these two forces should be equal. So we're going to say that the force of friction maximum is equal to 160 newtons as well. And our normal force, we already said, because these two forces are equal and opposite, the normal force should also be 300 newtons. So now we have what we need in order to solve this problem. So if we divide both sides by n, then the n's cancel, and we're left with the coefficient of static friction is equal to the force of friction divided by the normal. Put the numbers in, 160 newtons divided by 300 newtons, and we get a coefficient of static friction equal to 0.53 as our final answer. And that's how you'd solve that problem.